Alright, let's consider a triangle PQR with points P, 3, 4, Q, negative 5, 2, and R, 1, negative 4. And what we're going to do is we're going to draw this triangle out and we're going to look at three things. The median, so we're going to be looking at the median, the altitude, and the right bisector. Okay, so these are different types of lines that will exist in different shapes. We're going to specifically use triangles. Now, to do this, I'm just going to create a Cartesian plane to sketch these points out. So here's my Cartesian plane, and what I'm going to do is I'm just going to plot these points out to construct our triangle in question. So point 3 and 4, let's put that here. Okay, and this is point P, this is 3 and 4. Right, we'll put point Q, negative 5 and 2 somewhere here. And we're going to put R, 1 and negative 4 here. Okay, so this is our triangle, and I'm just going to connect the points. Oops. So you're going to try to use a ruler for this, guys. Whoops. Okay, well, it's supposed to be a triangle, not quadrilateral. But I think you guys understand what I'm trying to do here. Okay, so this is our triangle. Alright, so this is our triangle, and what we're going to do is we're going to look at the different types of these lines, the median, the altitude, and the right bisector. So let's start with the median. So the median, this in blue, we basically have, this triangle is called triangle PQR, right? So we have triangle PQR, and each of these points in green are basically vertices. Okay, so each of these points are vertices, or the singular term would be a vertex, right? And basically a median is a line that intersects another line at its midpoint. Okay, so in order to find the midpoint of a line, you guys can use this equation. The midpoint is equal to x1 plus x2 divided by 2 and y1 plus y2 divided by 2. It's basically the average point between the x and y values, right? Now, so the median is a line that intersects another line at its midpoint, and what we can do here is we can extend a median from each vertex of the triangle, right? So for instance, we can start with vertex P. So I'm just going to draw the median out in red here. So you can start from vertex P, and basically you can extend a line to the midpoint. I'm just kind of sketching it out, but you can extend the line to a midpoint of line segment QR, right? So in order for us to determine where the median hits, we need to find the midpoint of QR, right? So this is the midpoint of QR. So if we want to determine the midpoint of QR, we can just use that equation, right? But we can also extend a median from the other vertexes. We can also extend a median from vertex Q. And this basically hits the midpoint of the opposite side, PR, right? So this basically hits the midpoint of PR, right? And so we can also find the midpoint of PR by using this equation, and that's basically working with the line segment P and R, right? Excuse me. So this is basically the median from vertex Q. This guy here is the median from vertex P. So each median is labeled after the vertex that it originates from. And we can also have, lastly, we can also have a median from vertex R, right? So the median from vertex R extends from point R all the way to the midpoint. Once again, I'm sketching this out, guys, but to the midpoint of PQ, right? So this is the median from vertex R. Okay, and where all three medians meet, this point here, it's given a special name. It's a point of intersection, right? It's when all of these three lines will meet. It's a point of intersection. This is given a special name, and this is called the centroid. The centroid is the point of intersection between all three medians, or two or more medians, at least two or more medians in a triangle, right? So a centroid is a point of intersection between at least two of the medians of a triangle. Now we can classify medians by using an equation of a line, right? So for each of the medians, we can classify them by using a respective equation of a line. And we can determine the equation of a line because we have the 2 points, right? We have the originating point and we also have the midpoint. Okay, so that's the idea of medians. So next we're going to look at, so now let's actually calculate for the median from each vertex. So in this case, I'm going to find the median from vertex R. We're going to use the same triangle. And in this case, we have point R at 1 and -4. So I'm going to start here. And if we are looking at the vertex, if we're looking at the median from vertex R, the median is going to extend from vertex R and hit the midpoint, right? You're going to use a ruler for this, guys. It's going to hit the midpoint of the opposite side, right? So it's going to hit the midpoint of QP, okay? So in order for us to start off, let's find the midpoint of QP. So to find the midpoint of QP, we can use the equation x1 plus x2 over 2 and y1 plus y2 over 2, right? So Q here we have -5 and 2, R is 1 and -4, so I'm just going to make R 0.1, so this is x1, this is y1, I'm going to call this guy x2, this is y2, okay? And you just plug it into the equation. So in this case you get 1 minus 5 over 2 and -4 plus 2 over 2, right? And this is midpoint QP, and the midpoint QP here is -4 over 2 and -2 over 2, and you basically get -2 and -1. Okay, so you get -2 and -1. Okay, so that's your midpoint, and that's the idea. Now, once you have the midpoint and you have the point that it originates from, the median where it originates from, now you have 2 points that make up the line. So this is the median from vertex R. Okay, so that's the median from vertex R. If you want to find the equation of that median, we have the 2 points, we can find the equation of the line. So we want to look at the equation of the line as y is equal to mx plus b. I'm going to change the color just so we can show a different step in our process here. Y is equal to mx plus b. Right, let's find the slope and let's find the y-intercept. Right, so the slope here, we can use the equation y2 minus y1 over x2 minus x1. Right, and in this case, I'm just going to stick with my original case. I'm going to call this guy x1, y1. I'm going to call the midpoint x2, y2. Right, so the midpoint here we said was -2 and -1. Okay, and I'm just going to plug it into the equation. So if I plug this into the equation, yep. Okay, so let's plug this into our equation. So in this case we have, so y2 here was going to be -1, y1 here is -4, x2 here is -5, oh sorry, it's -2, looked at the wrong point, it's -2. Right, so when you guys are doing the substitution, make sure you put these brackets because you have to do integer operations. And x1 here is 1. So you basically get -1 plus 4, which is 3, and -2 minus 1, which is -3, so you get -1. Okay, so that's the slope of your median, right? That's your slope of the median, and the next thing you want to do here is you want to basically solve for the y-intercept. Right, so now your equation looks like this. Y is equal to -x plus b. In order to solve for the y-intercept, you're going to substitute a point. So I'm going to substitute the point -2 and -1. Right, so if you substitute the point -2 and -1, you basically get -1 for y, -2 for x, plus b. You get -1 is equal to 2 plus b. and then b here is -1 minus 2, which is -3. So the equation here is y is equal to -x minus 3. So this is the equation of the median from vertex R. Okay. Let's do another question where we're going to be finding the median from another vertex. I'm going to do this from vertex Q this time. Okay, let's find the median from vertex Q this time. So if we're finding the median from vertex Q, so this was our previous median from vertex R. So the median from vertex Q is going to start at vertex Q and hit the midpoint of the opposite side, PR, right? So this is the midpoint of PR. So the first thing you need to do here is you need to find the midpoint of PR, right? So the midpoint of PR is equal to 1 plus 3 over 2 and -4 plus 4 over 2. Okay? So we're basically using the midpoint formula, x1 plus x2 over 2 and y1 plus y2 over 2. Okay, so that's the idea. And you basically get 4 over 2 and 0 over 2. The point here is 2 and 0. Okay, so that's the midpoint PR, sorry. Okay, so that's your midpoint PR. This is 2 and 0. And the next thing you want to do here is you have the 2 points and you want to find the equation of the median, right? So this is the median from vertex Q, right? And if you want to find the equation, we can understand that the median's equation is the equation of a line, y is equal to mx plus b. And you want to solve for m, you want to solve for b. And in this case, to solve for m is basically y2 minus y1 over x2 minus x1, right? So y2 minus y1, in this case, you can call this guy x2, y2 if you want. You can call this point 2 if you want. It doesn't really matter what you call point 2 and what you call point 1. We'll call this point 1, so this is x1 and then this is y1. Okay? Whoops, let me just change that. Okay, and then you can just subtract it. So y2 here is basically 0, y1 here is 2, x2 is 2, x1 is -5, and you get -2 over 7. Okay, so that's your slope. And once you have your slope, you can just plug it in. So y is equal to -2 over 7x plus b. Now the next thing you want to do is solve for b, your y-intercept. Right? In order to solve for b, you need to substitute a point that exists on the line. Well, we have 2 points that exist on the line, the midpoint as well as the originating vertex. I'm just going to plug in the originating vertex. So let's substitute, let's use a different color here. I'm going to substitute the point -5 and 2. We know this exists on the line because it's part of the vertex. And if I plug in this for x, plug in this for y, you basically get 2 is equal to -2 over 7 times -5 plus b, and in this case you get 2 is equal to 10 over 7 plus b, and you need to change the common denominator, so I'm going to multiply this by 7. You get 14 over 7 is equal to 10 over 7 plus b. I'm going to move the 10 over 7 to the other side. B here is 14 over 7 minus 10 over 7, which is 4 over 7. So therefore the equation of the median from vertex Q is y is equal to -2 over 7x plus 4 over 7. Okay. Now that we have 2 equations of medians, so we have the equation of the median from vertex R and the equation of the median from vertex Q, we can also find the centroid. And we said that the centroid is the point of intersection of the 2 medians, right? So this is the centroid. Okay, and it's at least 2 medians. You can have up to 3 medians, right? Because if you get the median from vertex P and you extend it, well, we'll use a different color for this. You extend it, let's use green, right? So you extend it from vertex P, it's going to cross through the centroid and hit the midpoint, right? And I'm just sketching this out, guys. This is like, it's ballparking the point, right? But you can see that it basically also crosses through the centroid. So the centroid is at least the point of intersection between, it's the point of intersection between at least 2 medians, right? So that's what you want to kind of get from that. So now that you have the two equations, you can actually calculate the centroid. Because it's a point of intersection, we can just use the substitution method, right? So if we're using the substitution method, this is one of the equations for a median. This is the second equation of the median. At the point of intersection, so at centroid, which is a point of intersection, right? I'm going to call this guy y1, I'm going to call this y2. y1 should equal y2. At any point of intersection, you're going to have a common x and y value. So if I equate these two equations, then negative x minus 3 for the equation of the median from vertex R should be equal to negative 2 over 7x plus 4 over 7. This is the equation of the median from vertex from vertex Q, right? So then what you want to do here is combine the like terms, right? So I'm just going to move the x terms here, the constants over there, right? So you have negative x plus 2 over 7x is equal to 4 over 7 plus 3, right? If you want to make your life a lot easier and you don't want to work with these fractions, I'm just going to multiply everything by 7, right? So if you multiply everything by 7, you can also find a common factor, it's up to you. Multiply everything by 7, you get negative 7x plus 7 times 2 over 7x is equal to 4 over 7 times 7 plus 3 over 7. Now you don't have to do it this way, but it is easier if you don't want to work with fractions. So you get negative 7x, cancels out, plus 2x is equal to 7 divided by 7 is 1, 4 plus 21. So you end up with negative 5x is equal to 25. If you divide by negative 5, x is equal to negative 5. Okay, so the x value of the point of intersection is negative 5. If you want to find the y value, all you have to do is plug it into one of the two equations we use. We can either plug it into the equation of the median from vertex Q or the equation of the median from vertex R. I'm going to use the equation of the median from vertex R because the values are a lot easier. So y is equal to negative x minus 3, right? So y is equal to negative x minus 3. I'm going to substitute, right, this value in. So I'm subbing this value into the median equation. And in this case, y is equal to negative 5 minus 3. So y is equal to 5 minus 3. Y is equal to 2. Okay, so the point here is negative 5 and 2. Okay, and this is your point of intersection, and there, essentially, this is what the median is. I mean, this is what the centroid is. The centroid is a point of intersection. So in this case, if we're looking at the centroid, alright, let's take a look at an altitude within a triangle. So an altitude is another line, and an altitude specifically is a line that intersects another line at a 90-degree angle. Right? They intersect at a perpendicular angle, and the altitude is just another word for height. Height is always going to be from a 90-degree angle from a base, right? So let's take a look at the altitudes that can be present here, and an altitude will extend from each vertex, right? So we have three vertexes here. We have vertex P, Q, and R. You're going to have an altitude from each vertex. So the altitude from vertex P, let's say we start from vertex P, and we basically get to a point on the opposite side length, right, or the opposite line, QR, and it's going to create a 90-degree angle. Now, the altitude doesn't hit at the midpoint, right, so it's just any other arbitrary point, right, but we want to find the equation of that line. So this is the altitude from vertex P, okay, and subsequently, you can also have an altitude from the other vertex, so we can have one from vertex Q. So let's say this is the altitude from vertex Q. It creates a 90-degree angle. I'm just kind of sketching this out for you guys. I just want to show you guys what this looks like. But the idea at the end of the day is it will help you to kind of it will help you to visualize the altitudes, the medians, the right bisectors if you actually construct a triangle. So I would advise you guys, I would recommend it if you actually sketched out the triangle and then did this. So anyways, you can also have an altitude from vertex Q. Okay? And you can see that these two altitudes, they meet at a point, and this point here, the point of intersection of all the altitudes, this point here is called an orthocenter. So an orthocenter is a point of intersection between at least two altitudes. Right? We know that you can have a maximum of 3 altitudes in the triangle, but at least 2 of them will intersect at this point. So this point is actually common for all 3 altitudes, right? And you're going to see that, and you can actually solve for this point because it is a point of intersection by basically solving for a linear system. Okay, so what we want to do next is we also want to look at the third altitude. Let's use blue for this, and this is going to extend from vertex R, right? So it's going to extend from vertex R, it's going to cross the orthocenter, and let's say that ends up here. Okay, so this is the altitude from vertex R. Now, the idea here is if you want to find the equation of an altitude, you know that there's a single point on the altitude, and I'll show you guys how to do this later, but there is going to be a single point on that altitude. So the point that we have on that altitude is going to be the originating point, that basically where the altitude starts from, right? Whichever vertex the altitude starts from, right? So it's going to contain each of these 3 vertexes, but also the slope of the altitude is going to be 90 degrees to the opposing side that it intersects, right? So for instance, if we're looking at altitude from vertex R, it's going to intersect line segment QP. We can understand that the slope of altitude from vertex R is going to be a negative reciprocal of the slope of line QP, right? So we can say that. So if we're looking at vertex R, for instance, and just me kind of explaining this process out, that the slope of QP is going to be the negative reciprocal to the slope of the altitude, right? And a negative reciprocal indicates that the 2 lines are perpendicular, right? So for instance, if the slope of the altitude from vertex R was 2/3, the slope of line segment QP would be -3/2, and vice versa. Okay, so that's really the idea. So that's what an altitude is. And so it's important to understand what an altitude is from each vertex and this notion of the orthocenter. And we're going to be calculating for these cases. Alright, so this time we're going to find the equation of the altitude from vertex P. So if we're looking at an altitude, we basically start at the vertex and we extend the line downward, and it's going to basically hit the opposite side, side length at a 90-degree angle. Okay, so in order for us to find the equation of the altitude, y is equal to mx plus b, because it is a line, we need to first find the slope, and then we can find the y-intercept. Now we can understand that the altitude, so this is the altitude from vertex P, right? It's going to contain the point P, so it's going to have point P 3 and 4, right? And we also know that the slope of the altitude should be the negative reciprocal of the slope of the opposite side, QR. Okay, so let's find the slope of QR. So the slope of QR is basically, we're going to use the equation y2 minus y1 over x2 minus x1, right? And I'm going to just make this guy 0.2, I'm going to make this guy 0.1, right? So this is basically y2, this is x2, this is y1, this is x1, and we're going to subtract it. So we're going to get -4 minus 2, right? And when you're doing these substitutions, use brackets. x2 is 1 minus -5, and you get -6 over 6, which is -1. Okay, so slope here is -1, and in this case, we know that the slope of the altitude is going to be the negative reciprocal of that. So the negative reciprocal of -1 over 1 is just 1. The slope of the altitude is 1, so the equation here is y is equal to x plus b. And the next thing you want to do here is you want to substitute to find your y-intercept. So I'm going to plug in one of the points on the altitude, and we said that the point 3 and 4, the vertex exists on the altitude. So I'm going to substitute, let's use a different color here, I'm going to substitute the point 3 and 4. So if I plug in the point 3 and 4, I'm going to plug 4 for y, 3 for x, plus b. I'm going to move the 3 to the other side. B is equal to 4 minus 3, which is 1. So the equation here, y is equal to x plus 1. Okay, so y is equal to x plus 1, and that's the equation of our altitude from vertex P. Now, I want to find the equation, if I want to find the equation of another altitude, let's say we're finding the equation of altitude Q. I'm going to start from this point. Okay, so if I'm finding the equation from altitude Q, I'm starting at this point and I'm basically drawing a line down. It's going to hit the opposite side, PR, at a 90-degree angle, right? And it's going to contain the point P. So point P here is, well, point Q, sorry. Point Q here is -5 and 2, right? And because it hits the opposite side, PR, the slope of PR here, it should be a negative reciprocal of the slope of the altitude and vice versa. Okay, let's find the slope of PR first. So slope of PR, we use the same notion, right? I already said that this is point 2, so let's make this guy point 1 in this case. This is x1, this is y1, right? Let's call this point 1. So the slope of PR is basically -4 minus 4 and 1 minus 3. Okay, I'm just going to clean this up a little bit. Right, so you get -8 over -2, cancels out, you get 4. Okay, so that's your slope of PR. And then we know that the slope of the altitude from vertex Q is equal to -1 over 4, right? So this is the altitude from vertex Q. Okay, and now that we have the equation of the altitude, y is equal to -1/4 x plus b, right? We have one piece of the equation. We want to solve for the y-intercept. We know that the altitude is going to encompass our vertex, so we're going to substitute q, -5 and 2, and you basically get 2 is equal to -1 over 4 times -5 plus b. 2 is equal to 5 over 4 plus b, and move this to the other side. B is equal to 2 minus 5 over 4. B is equal to 8 over 4 minus 5 over 4, which is basically 3 over 4. Okay, so B is 3 over 4, so the equation here is y is equal to -1 over 4x plus 3 over 4. Okay, we also said that where the altitudes intersect is called the point of intersection. The point of intersection is called an orthocenter. Okay, so let's say we want to calculate the orthocenter, right? So if we want to calculate the orthocenter, well, I have two equations, right? I have the equation from the altitude that extends from vertex P, right? So this is from vertex P. Y is equal to x plus 1. This is my equation. And from vertex Q, we just found that the equation of the altitude is y is equal to 1/4 x plus 3 over 4. We know that at this point, the orthocenter, it's a point of intersection. You can equate, we'll call this y1, we'll call this y2. At the orthocenter, because it's a point of intersection, y1 is equal to y2. So x plus 1 is equal to 1/4 x plus 3/4. And if you want to get rid of the fractions, you can multiply out. So I'm just going to erase this out here. And let's say that we wanted to equate these two and find the point of intersection, right? I'm going to let y1 equal y2. So y1 is x plus 1, y2 is 1/4 x plus 3 over 4. You got this. And then I'm going to multiply everything by 4. So 4 times x plus 1 is equal to 4 times 1/4 x plus 3/4. If you basically expand this, you get 4x plus 4 is equal to 4 times 1/4 plus 4 times 3 over 4, right? Cancels out. You get 4x plus 4 is equal to 1 plus, this should be 1x. So this should be x plus 3, right? And if I move the x to the other side, 4x minus x is equal to 3 minus 4. 3x is equal to -1. X is equal to -1/3. Okay, so this is the x value of the point of intersection. If you guys want to find the y value, right, I'm just going to make a space here, but if you want to find the y value, you can just substitute it into the equation from the altitude from vertex P, right? So sub x is equal to -1/3, y is equal to -1/3 plus 1, and 1 is basically 3 over 3, so y is equal to 2 over 3. So the orthocenter, let's use point here. So the orthocenter, and we've actually calculated it, the point of intersection is 1 over 3, and we calculated here was 2 over 3. Okay, so this point here is 1 over 3 and -1 over 3 and 2 over 3. So that's how you can calculate the orthocenter, and that's how you can calculate the altitudes. Okay, so that's really the idea. We just kind of put everything together. Alright, so Ron and Mary are hiking on the Rideau Trail in Frontenac Provincial Park. They have reached the point that has a coordinate 2 and 4. Find the shortest distance from this point to a river flowing from points -7 and 6 and -5 and 2. I'm going to sketch this out so you guys can see what this looks like. Okay, so if I sketch this out, we have 2 and 4. So basically, it tells us that they've reached the point that has a coordinate 2 and 4. And so they're located somewhere here. Okay, so this is basically where Ron and Mary are. Let's call this point A. And there's a river that's flowing from -7 and 6 to -5 and 2. Okay, so let's do, here's a river, -7 and 6. Okay, so there's a river here, and it flows from -7 and 6 to -5 and 2. Let's say that it flows to here. Okay, so this is your river. Let's do that again. This is the river, and they want to figure out the shortest distance from this point to the river. Now to find this, to find the shortest distance from the point to the river, the shortest distance from a point to a river is always going to be a 90-degree angle. It's always going to be an altitude. So that's something that you want to remember, guys. Right, so the shortest distance from a point to a line is an altitude. Now we need to figure out first the equation of the altitude, but we also need to figure out the point that intersects this line, this river, right? So first let's find the slope of this altitude. Okay, so this is the line segment, this is going to be our altitude. Let's find the slope of the altitude. Let's find the equation of the altitude. Okay, now we have the points of the river. The points of the river are -7 and 6, and we also have -5 and 2. Okay, we know that the slope of the altitude is going to be the negative reciprocal slope of the river, right? So let's find the slope of the river. So I'm going to use R for river, right? You basically have 6 y2 minus y1, 2 over x2, -7 minus x1, -5, and you get 4 over -7 plus 5, which is 4 over -2, which is -2. Okay, so the slope of the river is -2. So the slope of the altitude should be the negative reciprocal because it is a 90-degree angle. Okay, the slope of the altitude here should be 1/2. Okay, so now the equation of the altitude is 1/2 x plus b. Now the next thing we want to do here is we want to figure out the intercept, right? So to find the intercept, y is equal to, I'm going to plug in, I'm going to substitute point A, and point A here was given as 2 and 4. I'm going to substitute 2 and 4, and you basically get 4 for y, 2 for x, plus b, so So 4 is equal to 1 plus b is equal to 3. Okay, so the equation here, y is equal to 1/2 x plus 3, right? This is the equation of the altitude. Now, we also need to figure out where does this line hit the river? What is this point? What is that point there? Okay, so let's figure out the equation of the river really quickly. Because in order for us to figure out where does this altitude hit the river, we need to find a point of intersection. Because this point here is a point of intersection. Right, so this red point here is a point of intersection. In order to find a point of intersection, we need to do substitution or elimination using the two equations. We know that the slope of the river we calculated was -2. So if you're looking at the slope of the river, the equation is y is equal to -2x plus b. To find the y-intercept, I'm going to substitute a point that exists on the river. So I'm going to substitute, let's say it's -7 and 6. So if I plug this in, you get 6 is equal to -2 times -7 plus b. 6 is equal to 14 plus b. I'm just going to move this down. b is equal to, if I move the 14 to the other side, -8. Okay, so b is equal to -8, guys. So the equation here is y is equal to -2x minus 8. Okay, so this is the equation of the river. Let's figure out where does this line hit the river. So we're going to do the substitution. So for finding point of intersection, let's call this y1, let's call this y2. The point of intersection occurs when y1 is equal to y2. So having said that, 1/2 x plus 3 is equal to -2x minus 8. And what I want to do is, if I want to get rid of the fractions, if I don't want to work with the fractions, I can multiply 2 to this side, and I can multiply 2 to this side. Just multiply by the lowest common denominator. You get 2 times 1/2 x plus 2 times 3 is equal to -2 x times 2 minus 8 times 2. And you can see that you get x plus 6 minus is equal to -4x minus 16. And then I can just move around the variables, right? So you get x plus 4x is equal to -16 minus 6. 5x is equal to -22. X is equal to -22 over 5. Okay, so that's your x coordinate. To find the y coordinate, I can just substitute this in. Let's sub this into equation, let's call this equation 2. Okay, so y is equal to -2 times -22 over 5 minus 8. Y is equal to 44 over 5 minus 8. Right, and 8 you can multiply this into 40 over 5. So it's 44 over 5 minus 40 over 5, and you get 4 over 5. So the point here is -22 over 5 and 4 over 5. So this is the point where the line hits the river, right? So this point here, I'll just make a note of this. This point here is, we calculated, was -22 over 5 and 4 over 5. Okay, so this is 4 over 5, right? And once we have this point, we have this point. If we want to find the distance, we want to find the shortest distance, right, from the point to the river, we can just use the length of the line segment equation. So we have 2 points now. We have this point, and we know that this is the point on the river. This is the point of intersection. The point of point A was 2 and 4. If you want to find the length is basically x2 minus x1 squared plus y2 minus y1 squared. Okay, so I can find the shortest distance now. So if I'm finding the shortest distance, what we could do, A, instead of writing 2 and 4, I'm going to write as base of 5, 10 over 5 and 20 over 5. Okay, so length is equal to 10 over 5 plus 22 over 5 squared plus 20 over 5 minus 4 over 5 squared, right? And you get this plus because the two negatives cancel out. And the length here is equal to 32 over 5 squared plus 16 over 5 squared. And you can punch this in your calculator, guys, to figure out what the value of this is, if you want to work through it. So the value here is Here is 7.155, and I think what we're looking at here, they didn't give us units. Let's assume that's meters. Because they didn't give us units, you can always just write units, right? But in this case, it's approximately 7.16 units. Okay, so that's the shortest distance from where they're located, from where Ron and Mary are located, to the river. So it is a really difficult, it is a really long question, but you have to break it down and just kind of test your understanding of it. Alright, let's consider a triangle PQR with points P 3, 4, Q -5, 2, and R 1, -4, and we're going to look at the right bisector. So what is a right bisector? So a right bisector is a line that intersects another line at its midpoint, creating a 90-degree angle. Okay, so it's a line that stems away from a midpoint and also creates a 90-degree angle. So it's a combination of the median and an altitude. Alright, so you can think about it as a median and altitude if you want to. Median plus altitude. Right? So if something bisects something else, it usually basically cuts it in half. A right bisector is basically, it cuts it in half and creates a 90-degree angle. Now, the thing about the right bisectors is that they don't actually stem away from the vertexes. They actually, or the vertices, they actually, they start from the midpoints. Alright, so this is what I mean. So let's take a look at line segment QR, right? Line segment QR is going to have a midpoint. Let's say it's somewhere here. And line segment QR is going to have a midpoint, the midpoint of QR. And from the midpoint of QR, and you can calculate that by using the midpoint formula, x1 plus x2 over y1, over 2, sorry about that guys, over 2, and y1 plus y2 over 2. Okay, so we can use this midpoint formula to find the midpoint, and we can draw a right bisector from the midpoint by just extending a line, right? So here is the right bisector from midpoint QR, and basically this line here has a 90-degree angle. So this is the right bisector from midpoint QR. It doesn't actually hit a vertex, right? It doesn't have to anyways. There are maybe some cases where it may pass through a vertex, but this is the right bisector. So this is the right bisector. So the right bisectors are actually labeled after the midpoints that they originate from. So right bisector from midpoint QR. We can also have, and because there's 3 midpoints in this triangle, we should have 3 right bisectors. We can also have another midpoint here. We call this midpoint QP, right? And basically the line that extends from midpoint QP creates a 90-degree angle, and this is basically the right bisector from midpoint QP. Okay. And we can also notice that these 2 right bisectors, they basically intersect at a point, excuse me, and this point here, this point of intersection, this point here is called the circumcenter. So the circumcenter is basically the point of intersection, of at least two or more right bisectors. Okay, so it is basically a point of intersection, guys, so you need to either use substitution or elimination with the equations of the right bisector, right? The third right bisector, let's do this in green, is going to extend from the midpoint of PR, so this is the midpoint of PR, right? And it's basically going to extend outwards. Whoops, let's do that again. It's going to extend outwards this way, right? And it's going to go through the circumcenter, right? So this is the right bisector, excuse me, bisector from line segment PR, okay? Or the midpoint PR. Okay, and all of these 3 will meet at the circumcenter. Now, if we wanted to find the equation of a right bisector, so let's say we were looking at right bisector from midpoint PR, right? The first thing we would have to do to find the equation of, I'm going to use RB for right bisector, and this is from midpoint PR. The first thing you'd have to do is first you got to find the midpoint of PR. This is going to represent a point on the right bisector, right? So you now have the point on the right bisector. Now you also need, we know that all of these cases are lines, so we can use the equation y is equal to mx plus b, and you have to basically solve for m and b, right? Well, we can solve for b by first finding m and plugging in a point. We know that one of the points, which is basically the midpoint that it originates from. Now to find the slope, we look at the line that it originates from and we take the negative reciprocal, right? So we know that the slope of PR, which is this line here, right? The slope of PR is going to be a negative reciprocal to the slope of the right bisector, right? It's going to be a negative reciprocal because they are 90 degrees. They intersect at 90 degrees fashion. They're perpendicular to each other, right? Negative reciprocal, right? So find the slope. Find slope of right bisector, right? It's the negative reciprocal of originating line. Okay, so it's negative reciprocal of the originating line. So keep this in mind, guys, to kind of look at this, right? And yeah, that's basically the idea of how to calculate a right bisector. So for the next couple of videos, I'm going to show you guys this example where we're actually going to calculate for the median, the altitude, and the right bisector. Alright, so let's consider a triangle PQR with points 3, 4, negative 5, 2, and R 1 and negative 4. So we want to determine the right bisector from the midpoint of QR. So once again, a right bisector is going to stem from the midpoint. So this is midpoint QR, for instance. It's going to stem from the midpoint, and it's basically going to create a 90-degree angle. Okay, the midpoint is a point on that right bisector. So what we want to do is first let's find the midpoint of QR. Okay, so let's find the midpoint of QR. If we want to find the midpoint of QR, we're basically adding these two and dividing by 2. So negative 5 plus 1 over 2, and 2 plus negative 4 over 2. You get negative 4 over 2 and negative 2 over 2, and you get negative 2 and negative 1. Okay, so this is your midpoints, negative 2 and negative 1. Once we have our midpoint, what we want to do next is we need to find the slope of the right bisector. Now the slope of the right bisector is going to be the negative reciprocal. I'm going to use RB for right bisector. It's going to be the negative reciprocal of the slope of QR. Okay, the slope of QR is basically negative 4 minus 2 over, and I'm just basically calling this point 2.1. So you can call this y1, x1, right? X2, y2, and then what you're going to do here is you're going to do x2, which is 1 minus negative 5, which is equal to negative 6 over 6, which is negative 1. So the slope of QR is negative 1, so the slope of the right bisector is going to be 1. Okay, so the slope of the right bisector is 1. So this tells us that the equation of the right bisector, y is equal to x plus b. And once we find the equation of the right bisector, once we find the slope of the right bisector, we want to find the y-intercept. Intercepts to a point that's found on the right bisector. Well, we know that the point negative 2 and negative 1 exist on the right bisector, so I'm going to substitute negative 2 and negative 1, okay, into the equation. So when I plug it into the equation, what's going to happen here is you're going to get negative 1 is equal to negative 2 plus b. Negative 1 is b minus 2. I'm going to move the negative to the other side. B is equal to negative 1 plus 2, which is 1. Okay, so the equation of the right bisector from the midpoint of QR is y is equal to x plus 1. Okay, so that's how you find the equation of the right bisector. So it's pretty straightforward. The first thing you want to do is find the midpoint. The second thing you want to do is find the slope of the line that it's originating from. So we found the midpoint here. Then we found the slope of the originating line. And we need to understand that the slope of the originating line and the right bisector are 90 degrees apart. So they should be negative reciprocals, right? And this was us finding the slope of the originating line. And then we found the slope of the right bisector, which was 3. We plugged it into our equation, and then we solved for our y-intercept by substituting the midpoint, which was the original point on the right bisector, and then we got the equation. So this is essentially the progression of steps that you want to take to basically solve this. Okay, so let's find the right bisector from midpoint QP this time. So midpoint QP is basically here. In the previous video, we found the midpoint. We found the right bisector from midpoint QR, right? And we show this out here. So this was the right bisector from midpoint QR. And we found the equation of that right bisector, which was y is equal to x plus 1, right? And my point of this, the point I'm trying to make here is that the two right bisectors will intersect and they will form a point of intersection called the circumcenter. So let's find the right bisector from QP this time. So the right bisector from QP is going to extend from the midpoint of QP, create a 90-degree angle to QP, and will intersect this other right bisector. And this point here is basically the circumcenter. It's the point of intersection between at least two right bisectors in a triangle. Okay, so if we're finding the right bisector from midpoint QP, let's find the midpoint of QP first. Okay, so the midpoint of QP here, right? I'm gonna call this guy point 1, and I'm gonna call this guy point 2. Right, this is x1, y1, x2, y2. Maybe I'll switch colors here so we can kind of see it a little bit better. So here I'm going to do negative 5 plus 3 over 2, and 2 plus 4 over 2. Okay, and your midpoint here is basically negative 2 over 2 and 6 over 2, which is negative 1 and 3. Okay, so this point here is negative 1 and 3. Okay, so that's your midpoint, and now what you want to do here is you want to create the equation. So once we found the midpoint, we need to find the equation y is equal to mx plus b. Well, we need to understand that we need to find the slope, and we need to find the intercept, right? So we know that the slope of the right bisector should be equal to the negative reciprocal of the slope of QP. Line segment QP, and because the right bisector and the line segment are 90 degrees apart, right? So if we look at the slope of QP, right, we basically get 4 minus 2 over 3 minus negative 5. So I'm using the y2 minus y1 equation. So you basically get 2 over 8. So this is 1 over 4. Okay, so this is the slope of QP, it's 1 over 4. So the slope of the right bisector, which is perpendicular to QP, is negative 4 over 1. Okay, so it's negative 4 basically. So the slope here is negative 4. So this is going to tell us that the equation is y is equal to negative 4x plus b. In order for you to solve for b, we need to plug in a point that exists on the right bisector. Luckily for us, we know that the midpoint, negative 1 and 3, exists on the right bisector. So I'm going to substitute the point, substitute negative 1 and 3 into my equation. So I plug in 3 for y, negative 1 for x. So 3 is equal to 4 plus b, right? If you look at this, b is equal to negative 1. So the equation here is basically y is equal to negative 4x minus 1. So this is the equation of the right bisector from midpoint QP, right? So the equation of this right bisector was negative 4x minus 1. we're not done yet. We want to find the circumcenter. So to find the circumcenter, we'll call this y2. We'll call this guy y1. At the circumcenter, it's a point of intersection. Let's use a different color. Let's use red actually. So at the circumcenter, y1 will equal y2. So technically x plus 1 will be equal to negative 4x minus 1. And then what I'm going to do is I'm going to rearrange the variables. X plus 4x is equal to negative 1 minus 1. You get 5x is equal to negative 2. If you divide by 5, x is equal to negative 2 over 5. Once you solve for x, you can substitute this in to find the y value of the point of intersection. Substitute x is equal to negative 2 over 5. Let's plug this into, we'll call this equation 1. So you're basically using the substitution method. Y is equal to negative 2 over 5 plus 1, which is 5 over 5. That's going to give you 3 over 5. So the point of intersection is negative 2 over 5 and 3 over 5. So this tells us that our circumcenter, this point in yellow here, is basically negative 2 over 5 and 3 over 5. So we can actually adjust our sketch and put it up a little bit higher, because once again this is kind of this was just us ballparking the image, but by finding the actual point we can actually determine exactly, with some degree of effectiveness, exactly where the point of intersection, the circumcenter, lies. So the circumcenter is just the point of intersection of at least two right bisectors in a triangle. Alright, let's consider a triangle with vertices Q, negative 2, 0, R, 2 and 8, and S, 7 and 3. We want to find the circumcenter, and just to kind of point out that the circumcenter is basically the point of intersection of all the right bisectors, at least two right bisectors of a triangle, right? So recall that a right bisector is basically a combination of a midpoint and an altitude. Excuse me. Okay, so let's find the circumcenter. I think just to start off, what would help you guys out would be to basically sketch out the triangle, right? So let's do that. Let's create a Cartesian plane. Let's sketch out the triangle. So I'm just going to do that here. Okay. Okay, so here's our Cartesian plane. I'm just going to plot some of these points. So we have point Q, so this is triangle QRS. Point Q is negative 2 and 0, so let's say that's right here. Okay, so this is point Q, this is negative 2 and 0. We also have R, which is 2 and 8, so let's put that here. This is point R. You don't have to do this, but it's great to visualize this so you guys can understand this better. And point S here is 7 and 3. So 7 and 3, let's say that's somewhere here. Okay, so this is point S, this is 7 and 3. So we'll just kind of connect this together. You're going to possibly, hopefully use a ruler for this. Okay, so this is our triangle. And the idea here is we need to find at least two right bisectors and then find the equation of those right bisectors and then solve for those. The system of equations. Alright, so to do this, let's start with one of the right bisectors. So the right bisectors actually start from the midpoint of the line segment. So I'm just going to pick a line segment and I'm going to find the midpoint. So let's start with QS. Right, so let's start with the line segment QS, which is this line here, and let's find the midpoint of QS. Okay, so let's find the midpoint of QS. So the midpoint of QS, we're going to use the formula x1 plus x2 over 2 and y1 plus y2 over 2. So the midpoint of QS basically looks like 7 plus negative 2 over 2 and 3 plus 0 over 2. Okay, so this gives us approximately 5 over 2 and 3 over 2. You can change this into decimals if you want because they are terminating fractions. So we can call this 2.5 and 1.5. Okay, so that's our midpoint. Right? This is going to be one of our points on our right bisector. And if we are going to look at our right bisector, right, our right bisector is going to stem from the midpoint and form a 90-degree angle. Okay? And we know that the equation of the right bisector is y is equal to mx plus b because it is a line. In order for us, we have a point that exists on the right bisector, which is this point here, but the next thing we want to do is we want to find the slope of the right bisector. So to find the slope of the right bisector, we can understand that the slope of the right bisector should be a negative reciprocal of the slope of QS. Okay, so, and this is because of the fact that they are 90 degrees to each other. So let's find the slope of QS. So the slope of QS, we can use the equation y2 minus y1 over x2 minus x1. So y2, 3 minus 0 over x2, 7 minus negative 2. So we get 3 over 9, right? So this is the slope of QS. And the slope of the right bisector is going to be a negative reciprocal, so we flip the fraction, we get 9 over 3, and we get a negative 9 over 3, which is negative 3. Okay, so that's the slope of the right bisector. So now the equation looks like y is equal to negative 3x plus b, and we want to plug in a point that exists on this right bisector. So I'm going to substitute, and I'm going to just kind of change colors here, but I'm going to substitute our midpoint, 2.5 and 1.5. When I plug this in, I get 1.5 for y is equal to negative 3 times 2.5 for x plus b, and we basically get 1.5 is equal to negative 7.5 plus b. B is equal to, if I move this to the other side, you're going to get 9.0. Okay, so the equation here, y is equal to negative 3x plus 9. Okay, so that's the equation of the first right bisector. So this right bisector that we drew out is basically y is equal to negative 3x. You know what, I'm just going to write it out here. So the equation of this right bisector from the midpoint QS, right bisector from midpoint QS, is basically y is equal to negative 3x plus 9. Okay, so that's the first equation. Let's find a second right bisector. We're going to do the same thing, so I'm just going to kind of speed through this. Let's find the right bisector from, let's take this point, the midpoint of QR, for instance. Okay, so let's take a look at the midpoint QR. So the right bisector would basically, if I extend it, it's going to create a 90-degree angle, and this is the right bisector from the midpoint QR. Okay, so let's find the midpoint of QR first. So the midpoint of QR is equal to negative 2 plus 2 over 2. Sorry, can't have something over 0. 0 plus 8 over 2. And in this case, you get 0 over 2 and 8 over 2, which is basically 0 and 4. Okay, so that's the midpoint QR. So this is 0 and 4. Right, and this is going to be a point that exists on our right bisector, and we can understand that the slope of the right bisector would be a negative reciprocal of QR. So let's find the slope of QR, which is basically 8 y2 minus y1 0, x2 2 minus x1 negative 2. So you get 8 over 4, which is 2. So the slope of the right bisector in this case is negative 1/2 because it's 2 over 1 and the reciprocal. Negative reciprocal is negative 1/2. Okay, so now that we have the slope, the equation is going to be y is equal to negative 1/2 x plus b. And we have a point 0 and 4, so I'm going to substitute that point in. So I'm going to substitute the point 0 and 4, but you guys don't even have to substitute this in because you know this is a y-intercept. So b here is 4, but you can actually just test that if you really want to. Y is 4, x is 0 plus b, and you can see that b is equal to 4. So the equation here is y is equal to negative 1/2 x plus 4. Okay, so that's the equation of this right bisector, right? So now we have this equation. I'm just going to write it out here again. And we know that the circumcenter is the point of intersection of the two right bisectors. So if this guy here is y1 and then this is y2, at the circumcenter, it's a point of intersection, y1 is equal to y2. So we can use substitution to equate the two equations and then solve for a point of intersection. So if I do that, I'm just going to use a different color. If I do that, I get negative 3x plus 9 is equal to negative 1/2 x plus 4. I should have wrote 4 here, not b. Sorry about that. Plus 4. Okay, I just made a little error there, but this is our equation, and in this case what we want to do here is we want to equate, we want to basically collect the like terms. So if I move the negative 1/2 x to this side, I'm going to move the 9 to this side. Negative 3x plus 1/2 x is equal to negative 9 plus 4. If you don't want to work with fractions, what you could do here is you could multiply everything by 2, right, because this is negative 5, and if I multiply this by 2 and this by 2, you basically get negative 6 plus x is equal to negative 10. So this is going to give us negative 5x is equal to negative 10. If you want to solve for x, divide by negative 5. X is equal to 2. Now that you have x is equal to 2, what you can do is substitute into, let's call this guy equation 1. Substitute into equation 1, just easier. You can use either or equation, doesn't matter. Y is equal to negative 3 times 2 plus 9, and you get negative 6 plus 9, which is 3. So now you can see that the point of intersection here is 2 and 3. Okay, so and that is basically the circumcenter, right? So that it does take a little bit of time because you have to find the two equations. And therefore, this point here, the circumcenter, the point of intersection, it's called the circumcenter. The circumcenter is basically the point of intersection of the right bisectors, and in this case, it's the point 2 and 3. So that's how you can solve for the circumcenter. Alright, so let's take a look at circles. A few things. We're going to be looking at circles where the center of the circle is the origin. So I'm just going to draw out a circle really quickly on a Cartesian plane. Okay, so this is our circle. Okay. Okay, so we'll just kind of see if I can correct that, but okay, just kind of assume that this is a perfect circle, guys. Anyway, so this is our circle. And a few things we want to look at here. This point here is called the center. Okay, and the center is basically equidistant from all the ends of the circle. And the outside of the circle, this blue line here represents the perimeter of the circle, which is given a special name. It's called the circumference, right? And the center is basically equal distance from all points on the circumference. So the distance from the center to the end of the circle is called the radius. So this here is called the radius. Okay, so the radius is defined as the distance from the center to the circumference of a circle. A true circle is basically going to have a constant radius. So wherever I look at the distance from the center to the edge of the circle, there should always be a radius. It doesn't matter if it's straight up or to the right or the left or a diagonal, there should always be a radius. Okay? So that's why you have to make sure you find an actual center. And in this case, the center, I placed it at the origin. So I placed the center here at the origin. The origin is 0 and 0. Anyways, another line that we need to look at, I'm going to do this in yellow. This line is called the diameter. And the diameter specifically is basically, it's 2 times the radius. Right, so if I use D to represent diameter, right, I'll use R to represent radius, right? So the diameter is 2 times the radius, so 2R, okay? And technically a diameter is a line, and this is really important, that crosses through the center of a circle from one point of the circumference to another. One point of the circumference to another. So this is really important to understand, right? And you can understand this equation, right? And the circumference, if you recall from previous grades, the circumference of a circle can be calculated by taking the diameter and multiplying it by constant pi, and we can abbreviate pi as 3.14, but pi is an irrational number. That means that it can keep going. You can find the values of this if you look it up. This is one of the equations regarding the circumference, or the perimeter, or the length outside, or the distance around a circle. But we can also equate that the diameter as 2 times the radius times pi, because the diameter is 2 times the radius. So it's you can call it 2 times pi times r if you want. So that's another equation for the circumference. Now, a few other lines associated, or a few other properties of circles. There's this other line here that we can call, we'll use a different color, we'll use green. This is called a chord. So a chord is basically a line. So this is a chord. A chord is basically a line that intercepts two points on a circle, and a point on a circle is any point on the circumference. So any point on the circle is a point that exists on the circumference of the circle. So any point on the circle will only exist on the outside of the circle. And a chord is basically a line segment that hits 2 points on the outside of the circle. However, it does not cross the center. So that's why it's different from a diameter, right? But however, it does still intercept 2 points on the outside of the circle. And one thing that we need to understand when we're looking at points on a circle is that all points on a circle will satisfy an equation of the circle, right? So they'll satisfy the equation of the circle, and basically that means that the points exist on the circumference. So the points will actually exist on the circumference of the circle. Okay, so the points will exist on the circumference of the circle, right? And to find the equation of a circle, we actually need to figure out the center of the circle. Now, if the center of the circle is 0 and 0, we can use this equation of the circle. And the equation of the circle is going to be x squared plus y squared is equal to r squared. So this is going to be our equation of the circle, as long as the center is at the origin. This is really important. Okay? And basically x and y are the points, because we can understand that these points are x and y. All these points in purple, well, in here this is green, but these points in purple are x and y. And you can change those values so they act as variables, but r here is constant. R is your radius, right? So the equation of this circle here, if I take a point here, like one of the points here is -3 and 0. If a point exists on a circle, right? Like if we have the point -3 and 0, if this point -3 and 0 exists on the circle, it should satisfy the equation of the circle. So let's plug this in, and because we can see here that the circle meets the first criteria, that it starts at the origin, that we can use this equation. So I'm going to plug in for x, I'm going to plug in -3, for y I'm going to plug in 0, so you get -3 for x squared, plus y I'm going to plug in 0 squared is equal to r squared, and then you basically can see that you get 9 is equal to r squared. If you want to solve for r, you just do the square root to both sides. R is equal to 3. So you can't have a negative radius. Normally it's plus minus, but you can't have a negative radius, so r is equal to 3. And in this case, the equation has to be in r squared, so the equation of the circle is x squared plus y squared is equal to 9. And that's the equation of this circle that will be true. And the radius is 3, and you can actually see that the radius is 3, guys. So if you look at this, from each end, it's 3. It's 3 units, right? So 3 units up, the point here is 0 and 3. 3 units down, the point is 0 and -3. 3 units to the right, the point is 3 and 0. 3 units to the left, it's -3 and 0. So that's essentially how you can find the equation of a circle, right? All points that exist on the outside of the circle will satisfy this equation of the circle. And this equation of the circle only works when the center is 0 and 0. But for the most part, those are the types of circles that we'll be working with. So try to understand this, and we'll do some questions regarding this. Alright, so a circle has a diameter with the endpoints A, -4, 3, and B, 4, -3. Calculate the center of the circle. Find the equation of the circle, and does the point 5 and 6 exist in the circle? And we said earlier that the equation of a circle where the origin is, or the center is at the origin, is x squared plus y squared is equal to r squared, right? And the center has to be at 0 and 0, that's the origin, right? Let's test to see if the center here is in fact at the origin. Now a diameter is referring to a line that basically will cross the origin, right? So if we did have to design a sketch of this, right, let's say this is my Cartesian plane. If I design a sketch of the circle here, right, -4 and 3, you would expect it, let's say it's like somewhere here. So this is like A, this is -4 and 3, right? And you know, B here is 4 and 3. Let's say it's like somewhere here. Okay, so this is like 4 and 3. And this is B. And our line is gonna basically extend like that. We wanna find the midpoint, right? Because we wanna see if the midpoint of its diameter is basically the center of the circle, right? Because we know that the circle is gonna extend out this way, right? So it's gonna use a different color for that, so just to show the circle. But you can see that the circle, if the circle did exist, is going to extend out this way. Let's see that let's see if the center here is actually the origin, right? So in this case, let's calculate the midpoint. So if I'm calculating the midpoint, of AB, you get -4 plus 4 divided by 2, and 3 plus -3 divided by 2. And you basically get 0 over 2 and 0 over 2. And that tells you that the origin, the midpoint is 0. The midpoint is the origin, 0 and 0. And the reason this tells us that this is the center of the circle, the diameter is 2 times the radius. So at the halfway point, this would be a radius and this would be a radius. And basically, the radius would be the same distance away from the center to the circumference. So this in turn tells us that the center, therefore the center of the circle, is 0 and 0, so that's the origin. Now because it is at the origin, we can utilize this equation, x squared plus y squared is equal to r squared. So find the equation of the circle. Well, for part B, we know that the equation is x squared plus y squared is equal to r squared. We need to solve for r squared. So we need to plug in a point into this equation to solve for r squared. However, we're given 2 points. We're given point A and we're given point B. So I'm going to substitute point A. Any point that exists on a circle will satisfy the equation of the circle. So that means that I can plug in the x and y value of this point into the circle and it should work out, right? So if I plug it in, I get -4 squared plus 3 squared is equal to r squared. And in this case, I get 16 plus 9 is equal to r squared. R squared is equal to 25. R is equal to 5. Okay? So this tells us that the radius is 5 units, right? So this would be 5 units. This would be 5 units. And the equation here would be x squared plus y squared. R squared is 25. So this is the equation of our circle in question. Right, so that's the answer for this question. And then the third question is asking us, okay, does the point 5 and 6 exist on the circle? Well, we know that any point that exists on the circle will exist on the circumference of the circle, such as that, right? And in this case, we're looking at the point 5 and 6. I'm going to substitute the point 5 and 6 into my equation. So this is the x value, this is the y value. And if you plug this in, when I plug in x is 5 and the y value is 6 squared, and I plug this in, you can see that 5 squared is 25, 6 squared is 36. This is not equal to 25, right? So you can see that therefore the left side is not equal to the right side. If the point doesn't satisfy the equation, then the point doesn't exist. DNA stands for doesn't exist, does not exist. It doesn't exist on the circle. So any point that exists on the circle, first of all, exists on the circumference of the circle, and second of all, will satisfy the equation of the circle. Okay, so those are a few questions regarding circles.